Okay, so for this video, I am going to go over this worksheet that you should have a hard copy of from your wonderful substitute. And remember, this is mine with the key, okay? We're gonna go over how to do it, but this is what I copied onto the board to show you how to do these, to walk through them with you. All right, so we've got our different stressors, and then they're asking for the direction of the shift, generally speaking, and then the effect on all the other things in there. All right, so first thing I want to do, remove SO2. So if I remove SO2, okay, I'm removing from stuff on the right. So if I take out some of the SO2, I'm now creating a gap there. So I'm going to shift towards it to make more of it to correct that. So my shift should be, and untap this, there. Shift should be to the right, okay? So if I'm shifted to the right and I'm favoring that right side, we're making more of those products, that means both of those products, right, should go up. They should increase because we're going towards that side. The SO3 being on the left then should be decreasing because we're going in the right direction. So we're using up our reactants to make more of our products, okay? For heating up a reaction, we don't have delta H for this one, but we do have the fact that heat is on the left side of it. So if I heat up the reaction, that's the bell, that means I'm adding in more heat. So if I add more heat here, that means my reaction's also going to go to the right to get rid of some of that excess heat to keep it in equilibrium. All right, so I'm gonna do the same thing. So if I'm shifting to the right, that means all of those things should be the same. That will decrease because again, I'm shifting away from this side. And those two should increase because I'm actually gonna be making more of those products away from the heat producing side, okay? Hold on 1 second. Okay, so no one comes in and messes up my video. Okay, lowering the pressure. So because this is a fully gas reaction, that's great. We can use changes in pressure that will change it, okay? But remember, you have to look at the moles on both sides. If the moles are equal, then a change in volume or pressure will not change it. But these don't look equal. We've got 2 moles over here of gas, and on the right side, we've got 2 plus 1 giving us 3 moles. So our pressure and volume changes are going to correspond to the amount of stuff we have on each side. So if I'm lowering the pressure, okay, so imagine I've crumpled up a water bottle, now I'm releasing it, right? I'm lowering the pressure, okay, so it's less pressure. That means I'm creating more space, more volume for stuff. So I can shift to the right because I'm shifting towards the side with more stuff. So if I'm lowering the pressure, I'm creating more space for more moles. So I would also shift to the right. And of course, then everything else accordingly will be the same for the same reasons, because again, we're shifting towards that right side, towards our product side. Okay, if I cool down the reaction, okay, opposite of this guy, right? One, we can deduce that it's the opposite, but if we actually want to reason it through, if I'm cooling down the reaction, that means I'm taking out heat from here. That means I'm creating a hole there. That means it's going to shift to the left, towards the heat producing side to balance it out. So I'm going to shift left, that's cooling our reaction down, okay? The effect on SO3 should be that it increases because I've shifted towards left, towards the heat producing side. Then these guys should go down because again, we're shifting away from them, so they should be decreasing. All right, last one, increasing O2. O2 is on my right side. So if I increase something on this side, that means we need to go away from it, shift away from it to get rid of it. So in other words, we're gonna go backwards and it makes more reactants instead of products because we wanna balance it out. So if I increase the oxygen, I'm gonna shift to the left. That means that my SO3, which again, we're shifting to the left, it's on the left side, should be increasing. And then my 2 products over here on the product side should be decreasing because again, we're going away from them, okay? So that is the whole first section, okay? Go ahead and try the bottom one. I would recommend that you look at the answer key just to put lines. There are about 4 of them where it doesn't pertain to it, so just go ahead and cross them out. I can also just show you on camera right now, okay? So there's a couple spaces, see amount of NaOH for the first one, this one, this one, this one, okay? There's 4 spaces where you're not actually gonna put something, all right? But go ahead and try that bottom one and ask for help if you need it. And then you'll be able to do your homework number 3, the Châtelier intro stuff. And again, don't worry about the colors. The color changing ones, we'll get there. Just worry about the concentration, temperature, volume, pressure changes. All right, good luck.